Welcome to the very foundation of physics. Before we can measure the universe, we have to agree on the rules of measurement. Every physical quantity is a number accompanied by a unit. Think of it like a language. We have our alphabet, which we call fundamental quantities. These are basic independent building blocks like length, mass, and time. Then we have our words, which are derived quantities. These are combinations of the fundamental blocks like velocity or force. Historically, scientists were completely divided. Some used the CGS system, measuring in centimeters, grams, and seconds. The British used the FPS system with feet, pounds, and seconds. And others used MKS, standing for meters, kilograms, and seconds. To end the chaos, the world united in 1960 to create the modern international standard, the SI system. The SI system is built upon exactly 7 base quantities: length in meters, mass in kilograms, time in seconds, electric current in amperes, thermodynamic temperature in kelvins, amount of substance in moles, and luminous intensity in candelas. But wait, NTA loves to test the exceptions. There are 2 extra quantities called supplementary units used for geometric angles. Plane angle is measured in radians and solid angle is measured in steradians. Listen closely, because this is a massive high-yield NEET trap. Both the radian and steradian possess highly defined SI units, but they are completely dimensionless quantities. Now, let us talk about the grammar of physics. If you want to survive NEET assertion-reason questions, you must memorize the strict NCERT spelling rules. Rule number 1, capitalization. When writing a unit named after a scientist like Isaac Newton, the full word is never capitalized. You write NEWTON in all lowercase, but its symbol gets a capital N. For normal units like the meter, both the word and the symbol are lowercase. The only exception, the liter. It uses a capital L, so it doesn't look like the number 1. Rule number 2, plurals and punctuation. Unit symbols never get a full stop and they are never plural. Writing 25 cms or putting a dot at the end is strictly incorrect. Rule number 3, the single slash. You can only use one solidus or slash in a compound unit. Meters per second squared is fine. Joules per Kelvin per mole using 2 slashes, absolutely banned. Rule number 4, the spacing trap. Spacing changes reality. Writing an m, a space, and an s to the power of -1 means meters per second. But if you remove the space, that m becomes the prefix milli, changing the entire unit to per millisecond. Rule number 5, prefixes. Prefixes like mega or nano must stick directly to the unit, no spaces. Also, double prefixes are illegal. We say 1 nanometer, never 1 millimicrometer. And finally, the mass anomaly. The SI unit for mass is the kilogram. Since it already has the prefix kilo built in, we do not stack prefixes on it. 1 millionth of a kilogram is a milligram, not a microkilogram. Let us tackle question number 1, straight from the NTA playbook, the dimensionless exception. Plane angle and solid angle are classified as supplementary units. Which of the following statements is correct regarding their physical nature? Let's do a quick concept check and look at the geometry. A plane angle theta is defined as the arc length divided by the radius. Dimensionally, arc length is just length L and radius is also length L. When you divide length by length, they completely cancel out. This leaves us with M0, L0, T0. It is perfectly dimensional. However, we don't just say the angle is 2, we say 2 radians. It is the one rare exception in physics that possesses a defined SI unit but absolutely no dimensions. Therefore, they are supplementary quantities having units but no dimensions. We eliminate options 1, 2 and 4. Option 3 is our correct answer. Moving to question number 2. This is a classic NTA trap. We need to identify the option that completely satisfies the strict NCERT spelling and capitalization guidelines. Let's do an error analysis on the options. Look at option 1. The force is 15 newtons with a capital N. This is incorrect. The rule states that the full word of a unit named after a scientist must always be written in lowercase. It should be a small n. Now look at option 3. The current is 5A with a lowercase a. Wrong again. The symbol for a scientist's unit, like the ampere, must be capitalized. It should be a capital A. How about option 4? 3 meters with a capital M. This is completely wrong. Normal units not named after a scientist are lowercase in both the full word and the symbol. It should just be a small m.
That leaves us with option 2, 25 joules written completely in lowercase with the symbol capital G. This is a perfect match for the NCERT guidelines. Option 2 is our correct answer.
Let's look at question number 3. According to NCERT Appendix A8, which of the following compound unit representations is strictly illegal? We have a few variations of units here. Let's do a quick concept check. The NCERT has a very strict rule for the solidus, which is the technical term for the forward slash. The rule states you can never use more than one solidus in a compound unit. Look closely at option 3, joules per Kelvin per mole. Notice the two slashes, J/K/mole. This double slash notation is strictly banned in physics. If you want to write it correctly, you must use a single slash with a space like J/K mole, or use negative exponents like J k to the -1 mole to the -1.
Question number 4 brings us to a massive make or break NCERT grammar rule, the spacing trap. A student writes m space s to the -1. Then they write m s to the -1 with absolutely no space between the letters. Do these mean the same thing? Let's look at case 1. When you include a physical space between the symbols, they remain mathematically independent. The m stands for meter and the s inverse stands for per second, meter per second. But watch what happens in case 2. When you remove that space, NCERT rules dictate that the first letter binds directly to the second unit as a prefix. That m is no longer a meter. It has morphed into the prefix milli. So expression 2 is literally per millisecond. Space changes physical reality. Expression 1 is meter per second, while expression 2 is per millisecond. This perfectly matches option 3, making it a correct answer. We have arrived at question number 5, our final challenge for this concept, the mass prefix anomaly. To avoid stacking prefixes, how must a mass value of 10 to the -6 kilograms be represented? The NTA loves this exact trap. Notice how option 1 suggests microkilogram. This is strictly prohibited. The SI base unit for mass is the kilogram, meaning it already contains the prefix kilo. You can never stack a prefix on top of another prefix. Instead, the NCERT rules dictate that we must attach new prefixes directly to the base word gram. Let's do the conversion math. 10 to the -6 kilograms is mathematically equal to 10 to the -6 times 10 to the power of 3 grams. By combining the exponents, we get 10 to the -3 grams. And what is the prefix for 10 to the -3? Milli. Therefore, the correct representation is exactly 1 milligram. We cross out options 1, 3 and 4. Option 2 is the correct answer.